So now that we've looked at trapezoids, parallelograms, rectangles, and rhombus, we want to look at the last of our quadrilaterals that we can use these basic formulas of midpoint, distance, and slope to try to prove that these figures work. Now, we focused a lot on the quadrilaterals, but this also works like triangles. I can use this information to prove something's a right triangle or an equilateral triangle, which we did earlier in the year when we first learned these formulas. But today, let's focus on the big one, squares. Squares are easy to work with, but they take the most work, okay? So let's start off by defining what is a square. So there's a lot of different ways to define a square. First of all, it's a quadrilateral. Let me get my pen here. Let's get the blue pen. There we go. A quadrilateral with all sides congruent and all angles congruent. Now, there's other ways you could say that. You could say it's a quadrilateral that's equilateral and equiangular. You could say it's a regular quadrilateral. You could say that it is a quadrilateral that is both a rectangle and a rhombus. Because the rectangle is equiangular, the rhombus is equilateral. So that's what makes the square the most work, because you actually have to show both of those. You have to prove it's a rectangle and prove it's a rhombus. Since we've already done both of these, it shouldn't be too hard to do. The good news is once you prove one of those, it's a little easier to get to the next one, okay? So there's two different methods to proving something is a square. First of all, I could start by proving it's a rectangle, okay? I could say, hey, this is a rectangle. If I know it's a rectangle, then I can show, well, actually, what's a nice, easy way to prove that it's a rectangle? Hopefully you were able to say, oh, use slope to show perpendicular sides, okay? So I would use slope to show consecutive sides are perpendicular. Now, remember when we proved rectangle, we actually used a slope to prove it's a parallelogram and then show one set of consecutive sides is perpendicular. That gave me my rectangle. So then I state, great, I have a rectangle. Once I know it's a rectangle, I have two different ways I could prove that it's a square. Because what do you know about the consecutive sides of a rhombus and a square? They are congruent. Okay, so a rhombus and a square both have congruent consecutive sides, which means if I have a rectangle that consecutive sides are congruent, I must have a square. What formula will I use to show sides are congruent? Good, I want to use my distance formula. Okay, and we only need to use it twice. One side, another side, show they're congruent, bam, you're done. What about the diagonals? What do you know about the diagonals of a rhombus, which would also be true in a square? The diagonals are perpendicular. Okay, so since the diagonals are perpendicular, what formula would I use to show that? Good, I would use my slope formula. So it is possible to use all slope formulas to prove it's a square. Use slopes to prove it's a parallelogram, same slopes to show that my sides are perpendicular, then the slopes of the diagonals to prove that those are perpendicular. There's my square, okay? Another method, method number two, now I'll show you examples of both of these. Method number two is prove it's a rhombus first. Now we can prove it's a rhombus using what formula? The distance formula. Distance formula, if all four sides are the same distance, so I would use distance to show four congruent sides. That gives me my rhombus. Once I know it's a rhombus, then I look for what makes it special to be the square? What properties of a rectangle does this rhombus also have? So what do you know about the consecutive sides of a rectangle? They are perpendicular. And what formula do I use to show sides are perpendicular? Slope formula. And again, just like when we did our rectangle to begin with, we showed it's a parallelogram and two sides are perpendicular. Bam, now that parallelogram's a rectangle. Once I know I have a rhombus, and two sides are perpendicular, then bam, that rhombus is now a square. What about the diagonals? What is true about the diagonals of a rectangle? Okay, they are congruent. So I can use which formula to show my diagonals are congruent? The distance formula. Good. So again, it's possible to use all distance formula to prove it's a square. Find the distance of all four sides, find the distance of the diagonals. So all four sides are congruent, show the diagonals are congruent, you're done. Okay, so there's multiple methods to do this. That's why I kind of need to see your work so I can actually see what's going on in your brain when we do these. So I'm going to do one example, two different ways. Your homework is just going to be to do one problem. So it's your choice which method you use. So for this, though, I want you to follow along. So let's prove that we have a square. I'm going to use the first method. I'm going to prove it's a rectangle first. So method one, prove rectangle, then the rhombus. Okay, so to prove it's a rectangle, I'm going to use my slopes. So the slope of PA, the slope of AR, the slope of RT, and the slope of PT. So calculate those four slopes. We'll come back and we'll do the next part of this. Go for it. Okay, so you've got all four slopes. Let's see what we know about this. So I see that PA and RT have the same slope. I see that AR and PT have the same slopes. Since I have the same slopes, what do we know this figure is? Okay, I know that PA is parallel to RT and AR is parallel to PT. Don't forget to write that when you're doing your problems. Therefore, PART is a parallelogram because opposite sides are parallel. Now remember, that got me that far, but now I need to show that parallelogram is a rectangle. So I take two consecutive sides. I can say that PA is perpendicular to AR. I know that because I can see that they are opposite reciprocals. When I look at these two sides, 1 and -1, because 1 is its own reciprocal, then the negative gives me the opposite. Okay, so I know those are parallel. Therefore, parallelogram PART is a rectangle. All right, so that's step one. I proved I'm a rectangle. Now I need to show that rectangle is a rhombus. Now you have two choices. I could find the slopes of the diagonals or the distance of two consecutive sides. This is where you really get to choose on your own. It doesn't matter which one you do. Just when you write it out, you finish it out right. I'm going to go with the distance, okay? Just so I can practice my distance formula. So I'm going to take two consecutive sides. Maybe I'll take PA and AR. So PA, using my distance formula, let me go back up to the top here. And what's the other one I wanted to do? AR, using my distance formula. So using those points, go ahead and calculate those two distances. Okay, so now I've got my two sides. I can now say PA, segment PA, is congruent to segment AR. Therefore, now watch how I write this. Rectangle, because I already proved it's a rectangle, PART is a square because consecutive sides are congruent. Okay, so a rectangle that has consecutive sides congruent is a square. Okay, out of curiosity, let's just get this real quick. If I wanted to prove, if I wanted to use the diagonals, slopes of diagonals to prove that this is a rectangle, what are the diagonals? Okay, your diagonals should be PR and AT. So that's why we can't use these slopes here. None of these slopes tell me anything about the diagonals. So if I wanted to find the diagonals, I'd have to use PR and AT to find the slopes of the diagonals. Okay, just keep that in mind. So that's method one, prove it's a rectangle, then the rhombus. Let's try a look at method two, prove it's a rhombus and then a rectangle. So I want to prove a rhombus, then rectangle. So to prove it's a rhombus, I'm going to use my distance formula of all the sides. So that's going to be PA, AR, RT, and PT. So calculate those distances, and when we come back, we'll look at our next part. Okay, so you got all four of your distances. You should know, since we're trying to prove it's a rhombus, you should expect them to all be the same. But you still need to show me your work, okay? You can't just go, okay, these are all the same. I know I'm done. I don't have to do anything. Show me all the work. Even though we did it in the previous problem, still show me your work, okay? So now I know all sides are congruent. Therefore, PART is a rhombus. Now we just need to show that it's a rectangle and we're done. Rectangle, I'm going to go with the traditional way of showing it's a rectangle. I'm going to go back to the definition and show that two sides are perpendicular. So I'm going to use my slopes. I don't really use the diagonals that often. I tend to go with the sides. So I want the slope of two consecutive sides. So I'm going to use my first two, PA and AR. PA, I want the slope of PA, and I want the slope of AR. Okay, so I'll get those numbers. Find me those two slopes, PA and AR. Go for it. Should be pretty simple, being that we already did it in the last problem. So if you're really taking your notes, you didn't have to do any calculations there. My slopes here, I can see that great. PA is now perpendicular to AR. I know this because I see that their slopes are opposite reciprocals. Therefore, again, let me call this thing what I already proved it is. Rhombus, PART, is a rectangle, or I'm sorry, is a square because consecutive sides are perpendicular. Okay, that makes it a square. Again, I could have gone with the diagonals. I could have showed that diagonal PR is congruent to diagonal AT. Could have done that using my distance formula, okay? But again, I tend to stick with the sides. A lot of times people get messed up when they start trying to mess with the diagonals. They use the wrong pieces. So that's all there is. A lot more work to work with the square. It's not difficult, but you do need to show all the work. So now you've got one problem to do, okay? Doing it on Kami so I can see what you're doing. Show me all your work. Show me your calculations. Write out what your conclusions are and your statements, okay? After that, we're just going to look at a lot of practice on this for the next few days, okay? See you later.